This is Masudi.
Hi guys, this is Omid.
Last session, we worked a bit on creating an executable and compiling our code manually with the command prompt tools that Kotlin compiler provides us. And I wanted to show you guys this is the website of Kotlin language, kotlinlang.org. And currently, we are on the version 1.4.10, and so they go ahead and they explain a bit. So you can try Kotlin writing program Kotlin here and run actually on the website, or you can see their reason for why Kotlin it is concise, safe, interoperable. The tools they are suggesting, the tools that you can use with for writing Kotlin applications. And as you can see, the first one is IntelliJ IDEA. This is actually their own tool, their own IDE. They are the JetBrains, and Kotlin is also their own product. So I want you guys to focus on this one, Standalone Compiler. This Standalone Compiler, this page describes how you can install the compiler itself and compile your code and run your code with the basic instructions and execute your code without any need for any kind of IDE. So all of the languages come with a tool set, with a product, with a compiler that you can download. For example, say you are writing Python application. You want to write Python or Ruby or C# or whatever, Java. In order to writing, for example, Python application, you should go to the Python website, download the compiler pack, the compiler product. It is a bunch of files, executable files, just that. There is no IDE. Then you put that compiler somewhere on your disk, and so in our case with Kotlin, let me show you the Kotlin compiler I've downloaded. By the way, you can download it. Just click on this version up here, 1.4, and if you scroll to the bottom, you'll see this section here, and you can download it, the Kotlin compiler version 1.4. You can download for Mac OS and Windows and Linux separately. You can download this one. It will work on, I think, on Linux. I'm working on Ubuntu. So I've downloaded, I've put it here. It has these folders and a bin file. All of the tools that you download, all of them has got a bin file. For example, let me show you other one. For example, if you download the Gradle build tool, you may not know what is Gradle, but just for the moment, it has got a bin file. And if you go to that bin file, you see a kind of executable file. For example, this .bat can be executed on the Windows command prompt, and this can be executed on Ubuntu terminal. Or, for example, the JDK itself, the Java Development Kit, has got a bin file. It has jar, Java, Java-C, and a lot of other executable files. This Java-C is for compiling Java applications. You can feed a bunch of .java text files to it and ask it to compile it for you. Or in our case, the Kotlin compiler has got bin, and it has Kotlin, Kotlin C, and other files, but we are interested in these two, Kotlin C or Kotlin compiler, and Kotlin for running a Kotlin application. So for actually for compiling, we will use this, but we cannot open terminal always in this path, in this folder, to access this Kotlin C. Yes, this Kotlin C is here. For accessing that, we should move to the go to this folder, developer Kotlin compiler bin, to actually be able to run this file. But this is not feasible for every executable file to go to that place first. There is a solution for that, and they say you should put the address of these executables to your environment path. So if you are using, for example, Windows, Mac, or Ubuntu, whatever OS you are using, it has got a feature named environment path, and they say you should put it there. You should put this address here, this absolute path to your bin file. And when you open a terminal or command prompt in Windows, for example, and it is not pointing to this folder. It is not pointing to this folder, as you can see. But if I write Kotlin C, that I'm executing this file, and I press enter, it will actually see that. It is seeing this file because it is searching for this file on the paths that has been added to the environment path. And I've added this. I've added this path to the environment path, and you can search to see how it is done on your operating system. So first thing first, this is the compiler. Go ahead, download it, put it somewhere, and add it to your environment path. That's the first thing. Second, for executing a Kotlin application is actually will be run on top of JVM, Java Virtual Machine. It's a JVM language, they say, because all of these .kt files will be compiled into .class files, not the class that you see in writing application. No. It will be compiled to some other files.
Some class.
Yes, intermediary files .class, and then you can give those .class files, or you can group them into a .jar. .jar file is actually nothing more than .zip. It's a zip file. If you open it, you can see all of the classes. These are your classes. Main kt.class, product.class, shopping cart.class. You can see all those. It has been compiled. We have written only one single file, but it has extracted all of those classes and compiled it into .classes files. And all we have to do here to run this application, I want to open a terminal here. I've added Java to the environment path. Java is for executing .class or .jar files. I have got a .jar file here, so I say please run this .jar named shop.jar, and I press enter and it executes that. So now we have this version 1.0 of our application. We can ship it to the customer, but we should ship the Java runtime environment as well. In order to run this application, the customer needs to have Java runtime environment. So if you are, for example, writing Android application, you've written Android application, what is the executable file of Android application? What is the output of compiling an Android application?
You mean the extension?
Yes, what is the file? What is that file that you use it to?
In my cell phone.
Yes.
That's that APK.
.apk, a file. So you've written an Android application, you compile it, it gives you a .apk
yes.
file. But that .apk file
has lots of this.
Contains all of your code, Java code or Kotlin code. It contains your resources. When it goes and it is installed on the device, on Android machine, on Android device, the Android device itself has got JDK or Java runtime installed on it. You don't have to install Java runtime environment on your device, on your
default,
mobile
device.
device. Yes, they have installed it, but on a desktop machine, for example, if it is Windows or Ubuntu or Mac, you have to ship that Java runtime or JDK along with the application. So, and you can also create a kind of executable. For example, in Windows, a .bat file, or in Ubuntu, it's .sh file. That when a user, a beginner user, for example, our customer, double clicks on that file will execute actually this code, java-jar. So we want to make it easy for our customers to use our application. Yes.
Yes.
But if we force them to always open a command prompt,
no, that's not good.
That is not a good thing. But say for the moment, just for the moment, we don't want to get those things now. Just say that our customer is some kind of a genius guy that if we say open terminal and just type these java-jar shop.jar and you will be able to use the application, he will be okay with that. Just just we want to
Don't
move on.
mention it now.
Yes, we want to move on. We don't want to get too into details because they are not our concern here. So we run our application. So you saw that this is our application, and without the need for example, IntelliJ IDEA, we can write our application. Yes. To prove that, let me just write. For example, what am I doing? Open terminal, gedit. For example, my first .kt. Let's write an application. Fun main, yes. Find main. And for example, print ln. Hello. There. And I save this file. Okay. This is my file. I can say Kotlin compiler, Kotlin C. Please compile my first file, this KD file. And also please include this runtime. Just forget about this for the moment. And output, for example, application.jar. I press enter. It is compiling now. If we have any kind of problem or compiler error, it will exit and it will show you which line, for example, the error. Now it is compiled. We see this application jar. For running that, it's actually a Java program. From now on, from this point on, it is actually a Java application. Kotlin actually runs on top of JVM, Java Virtual Machine. I say this jar application, and it is running my application, as you can see, without any need for IDEs. But when you want to write big applications, it is not actually feasible or doable without the help of IDEs. Because for example, say you've mistaken a T here, you have a typo here, and or for example, as you can see, it is just complaining. Just let me put the T back. It is complaining here. It is telling me right away
that is false.
I don't see any product. You are instantiating some kind of product, and I don't see that. Where is that product? You may have mistaken, for example. It is telling my mistakes right away, and it makes very easy for me for writing applications.
Understand there is a problem and what is the problem.
That's the purpose of IDEs, actually. So I just wanted to show you guys that we can ship our application like this. It should be a .jar file, and there should be a Java runtime environment folders along the application and an executable. So, and it is now creating this shop.txt, yes, on the working directory for persisting I believe, the products only. Yes, we can write. We can persist the other parts of the program, the application. We are not persisting the shopping carts or the customer names. We can also create a separate file for them and persist them as well.
Also modifying.
Yes. So
in our menu.
So let's continue the application from here. Just last session, I told you that we want to do a bit of retrospective. To look back to see what have we done, what is wrong with this application, or what are we going to do. So this is where is the main menu? This menu is pretty much all the features that the application is now providing. Yes, you can create product, create customer, create shopping cart. The modification is not working yet. We can print the product list, print the customer list. Yes, and actually, so and one thing to mention again, having this global state here is dead wrong. We should not do this. There are a lot of things wrong with this application. A lot of things. We have, for example, we have coupled the concerns, a lot of concerns together. For example, this is the concern of the UI, the user interface. but the creating a product itself is the concern of domain. We have so there is no actually a definitive architecture here that you can name it. You cannot say, for example, our application has some kind of architecture. You cannot see a specific architecture here. We've just written the application in like old days fashion, writing them line by line and just going ahead and writing and just, for example, at some point we come to realization that, wow, we have written thousands lines of code and we cannot maintain it anymore because there is no architecture here. So as you guessed, we have we have some very well-known predefined architectures. For example, you may have known, I just threw some names here. For example, MVM, MVVM, MVP, MVC, clean architecture, onion architecture, or ports and adapters, hexagonal architecture. These are the layered architectures. These are used for architecting our application. Now at this point our application is very small. It is 300 lines of code, but it is actually beginning to go messy. At some point we'll see we have tens of, for example, 100 classes, 100 .kd files, and it is going so messy, and we are not actually able to maintain that code and understand what it's doing or debug it. The other thing that is wrong with the application, the way we write code, is that we are not testing it. We are just testing it by running the application. So this is not the correct way of writing a program. You may, for example, work on a company that nobody actually writes a single test for the program it uses, it writes. But that's not the correct way of writing program. You must test your application not by running the application. You must write tests for your code to prove that it is not working wrong. It is working correctly at least. So that's another thing to keep in mind, that we will at some point introduce writing tests, not writing tests after the fact, writing tests before the fact. It means that we will write first the test and then we will write the code to satisfy that test. So that's another thing to bear in mind.
We will do that in the future.
Yes, yes. We just want you guys to move on, all of us at the same time, to see all these steps that, all of the people will have to take in this career. You want to be a programmer. You want to be a programmer, so at some point, at the start, you'll start programming like this, writing without taking care about the architecture, the global states, the intertwining, intertwining the concerns, and, for example, calling something from here that you should not do, for example.
But it works.
It works, and you
enjoy.
At first you enjoy it, but when at late nights you keep debugging, and you cannot find the reason why that your code doesn't work. That's where you miss these principles, these concerns that
at first that's hard. Doing these things is hard, but
yes,
that would be easiest things.
That's the reason at the first
maintaining and debugging.
Of course, the reason at the first place why we are doing the things in the wrong way here is because it's a journey, and we want to demonstrate to you guys that first it was this. There were no architectures. And then the applications grow and grow, and they come to conclusion that we must have architecture, we must write tests, and we must, for example, follow these principles for a reason. But it will be very silly to throw all of the principles at the first and at the beginning to you guys. These are the principles. You will see some days the reason behind of them, but just remember them, and that won't work.
Memorize them.
Yes, we don't want to memorize, and we don't want to accept something without feeling
We're going to use them when we need them.
Yes. That's why That's the reason why we didn't spend hours and hours and hours on first explaining the Kotlin itself and then entering the application.
Mhm.
We wanted to learn everything along the way on the path
Mhm.
together. First doing it the wrong way, and then we will refactor our code and we will see why we are doing, for example, applying this principle of TDD, test-driven development, and at that point you will understand and you will.
We are going to make it better, actually. That's
Yes.
not wrong because it works. But
Now it works. Now it is very small. The scope of application is very small. It's 300 lines of code,
Mhm.
and we have not seen any errors yet. Part of that is because I have experience with these things, and I'm actually writing the correct application program here. That may not be the case with you because you guys are beginners, and for example, you will have a lot of exceptions and errors. For example, you will have a typo here, and you will be confused why my application isn't just working. But you will grasp that skill along the way, the more you advance. And that's the reasoning. This is our retrospective to explain that all of the rights and wrongs of this application. So I say goodbye to you guys, and from the next session we will enter to the next phase, actually the next phase of the application. We'll focus more on we'll advance to more advanced things.
Thank you very much
Bye.
for watching us. If you have any question,
Yes,
comment it. He will answer.
yes, I promise that.
I'm not the person who can answer. Bye
He's
bye.
not the person with the answers. Bye.